Welcome to Deep Tech Dharma, an autonomy thesis. Imagine for a second that you own a house, a beautiful house. You spent years saving for it, building it, pouring your sweat into it.
Right. It's your dream home.
Exactly. You hold the deed. It is yours. But there is a massive catch. Someone sitting on the exact opposite side of the planet holds the master key to your electricity meter.
Oh, wow. Okay.
Yeah, they also control the vocabulary you're allowed to speak inside the house. Oh, and they own the proprietary tools you have to use if you ever want to fix your own roof or, like, build your own furniture.
That sounds incredibly frustrating.
Right. And if that landlord across the ocean decides to just flip a switch or hike their prices up by 300% or simply lock you out because they don't like a policy you passed, you have zero recourse.
It's a terrifying position to be in. The funny thing is, you're describing something that sounds like a bizarre dystopian real estate novel, but that is the actual, literal geopolitical reality for most countries today when it comes to technology.
Which is wild to think about. Welcome to this deep dive. Today we're looking at a stack of 5 absolutely fascinating startup dossiers that reveal a massive, quiet shift happening in the global power dynamic.
Yeah, it's a huge shift.
Because for years, nations have relied on a tiny handful of foreign giants for absolutely everything. The artificial intelligence we consult, the factory robotics that build our cars, even the plastic shrink wrap around the sandwich you bought for lunch.
Everything is imported, basically.
Right. So our mission today is to unpack a new blueprint for technological independence. We're going to look at how 5 Indian deep tech startups are basically taking that master key back.
And to really understand the scale of what they're doing, we should apply a specific framework to these dossiers. We can call it the autonomy equation.
The autonomy equation, I like that. How does it work?
So the idea is that whenever we look at a new piece of technology today, we shouldn't just ask the basic consumer question of, what does this product do?
Right, like how fast is it or whatever.
Exactly. Instead, we need to ask 2 very specific structural questions. Number 1, what foreign dependency is being broken here? And number 2, what sovereign capability is being built in its place?
Okay, let's unpack this. Because you clearly cannot build a sovereign nation if the brain running your banks, your schools, and your hospitals is ultimately controlled by a foreign server farm.
No, you really can't.
Which brings us to our first foundational shift, reclaiming the digital mind. Currently, when a farmer in rural India asks a voice AI for help identifying a crop disease in Marathi, the intelligence answering them is usually sitting in a server rack somewhere in California.
Yeah, and that geographic and cultural distance creates a severe vulnerability. I mean, those imported models reason in English first.
Right.
They translate into local languages second. That means cultural nuance is constantly getting lost or hallucinated.
Just total loss in translation.
Yeah, exactly. But zooming out to the macro level, it bills in dollars, and it's controlled by a foreign corporate entity. Any nation that runs its critical welfare programs or digital infrastructure on someone else's outsourced intelligence is quietly giving away a piece of its sovereignty.
Yeah.
Because if a foreign company or a foreign government leveraging that company decides to throttle your access, you are entirely at their mercy.
Which brings us to a company called Sarvam AI. The dossier on these guys is fascinating because the minds behind this aren't just trendy software developers chasing the latest tech bubble.
Oh, definitely not.
Vivek Raghavan and Pratyush Kumar are the exact same engineers who helped build Aadhaar. That's the system that gave over 1 billion Indians their biometric digital identity.
It's massive scale.
Yeah, they successfully built the digital fingerprint for a nation.
Right.
And now they're trying to build India a digital brain.
And the capability they're constructing is profound. They're training a homegrown full-stack AI model on Indian soil, rendering it natively fluent in 22 different Indian languages from the ground up.
Wow, natively fluent.
Natively fluent. But what stands out to me in their approach isn't just the software architecture, though. It's the unique role the state is playing here.
Yeah, usually you think of the government as a slow-moving regulator that gets in the way of innovation.
Exactly. But with Sarvam, the Indian government is functioning as the ultimate trifecta.
They're acting as the foundational customer, for one. Like, they're aiming to wire this voice AI into citizen services that will reach something like 800 million people.
Right. And they're also acting as the grant maker. Training these massive language models requires an unbelievable amount of compute power.
Which is super expensive.
Extremely. So the state is stepping in to subsidize access to roughly 4,000 NVIDIA GPUs. So Sarvam actually has the raw horsepower to train the model.
That is huge.
It really is. And finally, the government is playing the role of a patient investor, backing the entire ecosystem through the 10,000 crore rupee India AI mission.
So when a national government simultaneously buys from you, supplies your raw materials, and funds your runway, it cements a capability that no foreign vendor can easily unplug.
Right, it's the ultimate defense mechanism.
But Sarvam is solving for what we might call the public brain, like population-scale AI meant to talk to everyday people. Our sources highlight another company, H2Loop, which tackles a completely different, almost invisible problem.
Yeah, a much more secretive one.
Exactly. I call it the secret brain. Think about the code running inside a fighter jet's targeting system, or a medical pacemaker, or a car's anti-lock brakes.
Very sensitive stuff.
You absolutely cannot send that proprietary life-or-death hardware code to an external foreign cloud just because your engineers want to use a fancy AI coding assistant.
No, and this is a massive, often ignored blind spot in the current AI revolution. Software engineers working on highly sensitive hardware are effectively locked out of the AI productivity boom because of basic security protocols.
Because they just can't connect to the internet.
Exactly. A defense contractor cannot ping an external server. They're forced to choose between strict secrecy and modern speed. H2Loop is breaking that specific dependency by building a hardware-aware AI that is compact and efficient enough to run entirely air-gapped.
And for those listening who might not know the term, air-gapped meaning the computer is physically disconnected from the internet. There's no Wi-Fi card, no Ethernet cable.
Right. It runs completely locally isolated inside a secure facility. Building an AI that powerful but that compact is an incredible engineering feat.
Because normally, large language models require warehouse-sized server infrastructure.
Yeah, massive server farms. But H2Loop has compressed that capability so the AI can help write, debug, and verify the code on local machines.
So that highly sensitive firmware never, ever leaves the building.
Never. It never pings a server in another country. That is a sovereign capability built specifically for national security and advanced manufacturing.
Okay, here's where it gets really interesting, though. I have to push back on this whole premise for a second.
Oh, sure. Go ahead.
We're talking about true independence. But if the physical hardware itself, the massive clusters of NVIDIA chips powering Sarvam, or the specialized processors running H2Loop, if all of that silicon is still imported from Taiwan or the US, are we actually sovereign?
Mhm.
Or have we just moved the dependency one step down the ladder? It feels like building a fortress but buying all the bricks from your rival.
That is a completely fair challenge, and it's a vulnerability the sources themselves openly acknowledge.
So it's a known issue.
Oh, definitely. True chip independence, like fabricating your own advanced semiconductors, is a much longer, infinitely steeper road.
Right.
The physical hardware is absolutely still a massive dependency. However, you can't solve everything simultaneously. Owning the foundational model, the actual intelligence layer, is the critical first domino that has to fall.
You have to learn how to write the brain before you can start fabricating the skull it sits in.
Exactly. If you don't own the software, owning the silicon doesn't matter anyway.
I like that framing. But, intelligence doesn't just sit on a server generating text. It has to interact with the real world.
Right.
A brain in a jar doesn't build a car or assemble a smartphone.
Right.
It's not enough to own the digital intelligence if you still rely on rigid foreign machines to build your physical goods.
Which is a huge problem.
Yeah, and that takes us from software to atoms, reclaiming the physical world through adaptable robotics. There's a startup in this stack called SynLR that just blew my mind.
The transition into the physical world is where deep tech gets incredibly difficult.
Right, and I found this detail in the source is so strange and hilarious. Like, a multi-million rupee factory robot today can weld a heavy car chassis in 3 seconds with blinding, terrifying speed.
Yeah, they're incredibly fast.
But unlike an average 2-year-old child playing with Lego, that same multi-million rupee robot cannot reliably pick up a screw, look at a hole, and push it in without crossing the thread. The toddler wins the dexterity contest every time.
It's so true. And the reason for that is fascinating. For all their speed and power, traditional factory robots are essentially blind and dumb.
Blind and dumb.
Yeah, they do not see the world the way biological creatures do. They just repeat a pre-programmed spatial coordinate in a 3-dimensional grid over and over again.
So it's just like, go to point X, close claw, move to point Y.
Exactly. And if a part on the conveyor belt is even a millimeter out of place, or if the factory lighting changes and casts a weird shadow, the robot completely fails. It just grabs empty air.
Wow.
Yeah. For 40 years, giving machines true object intelligence, the ability to look at an object they've never seen before, figure out its geometry, and manipulate it on the fly, has been the holy grail of robotics.
And Sinaler's founders, Gokul N.A. and Nikhil Ramaswamy, decided to tackle this holy grail by looking at human biology instead of just writing more traditional code.
Which is a brilliant pivot.
The dossier says they use something called lens convergence to perceive motion, depth, and color. That sounds incredibly technical. How does that actually work in practice?
Well, think about how your own eyes work. If you close one eye right now and try to quickly grab a coffee cup off your desk, it's surprisingly difficult.
Yeah, your depth perception is totally off.
Exactly. You lose your depth perception. You might knock the cup over. Your brain relies on two separate eyes looking at the same object from slightly different angles.
Okay, that makes sense.
Your eyes physically cross or converge to focus on the cup, and your brain instantly calculates the distance based on that angle. Most machine vision today is essentially a one-eyed barcode scanner.
Oh, wow.
Yeah, it only recognizes flat images. It was fed in a massive training database.
So Sinaler is basically giving the robot stereo vision.
More than just stereo vision. They built a proprietary hardware system called CLX-01 that physically mimics the human eye's micro movements.
Wait, really?
Yeah, it perceives motion, depth, and color dynamically. It isn't just taking static photos, it is actively looking and adjusting.
That is insane.
It allows their flagship robot, Cyro, to look at a chaotic bin of unknown, shiny, or transparent objects and just pick them up. It doesn't need a perfectly lit, highly structured environment.
And it doesn't need to be retrained for months on CAD models of the specific screw it needs to pick up.
Exactly.
So applying our economy equation here, the dependency being broken is reliance on a small handful of foreign robotics giants who manufacture these incredibly rigid single-task machines.
Right.
Because right now, if an Indian manufacturer wants to make a totally new product, they basically have to rip out the old assembly line, buy entirely new foreign machines, and spend months programming them.
Which keeps global manufacturing power highly centralized. You're entirely dependent on those foreign suppliers for your industrial upgrades.
Right.
But the capability Sinaler is building is the foundation for what we could call a universal factory. Imagine decentralized microfactories spread across the country where the robotic arms are so adaptable they can assemble car engines on a Monday, get a software update, and be instantly ready to assemble consumer electronics on a Tuesday.
It's like the difference between a train stuck on a fixed track, where it can only ever go to one predetermined destination, and an off-road vehicle that can dynamically navigate any terrain or obstacle you put in front of it.
That's a great way to put it.
You are turning the physical factory itself into a piece of software that can be updated on the fly.
And it completely changes the economics of manufacturing.
What really stands out to me here is the contrast with the Sarvam AI story. With Sarvam, the state was heavily involved at every level. But with Sinaler, there is zero government backing.
None at all.
They're entirely VC funded. They are actively fighting what the industry calls the India discount, the unfair assumption that Indian deep tech is only suitable for the domestic market.
Right, which is a huge hurdle.
And despite that, they're selling this vision system straight to the world's biggest legacy manufacturers, like Audi and General Motors. This is sovereignty being built entirely by the private market, from India, for the world.
It proves that breaking a global dependency doesn't always require a top-down government mandate. Sometimes it just takes stubborn founders who are willing to rebuild the absolute foundations of a technology from first principles rather than copying what the West is doing.
So we've secured the digital brain, and we've given that brain highly adaptable robotic hands.
Yeah.
But what are those hands actually building with? And what is powering the factories they operate in?
That's the next big question.
Because the deepest, most invisible dependencies any country has are the raw materials and the fuels it has to import just to keep the lights on and the assembly lines moving. Let's look at how these startups are decoupling from oil.
We're moving from the realm of software and robotics into the physical limits of the planet itself.
Yeah. Let me share a striking fact from the sources with you listening.
Yeah.
As you sit here right now, there is a very high probability that you have microplastics inside your body.
It's so disturbing.
In your bloodstream, in your lungs, and most of it is shedding from everyday single-use packaging. The clear wrapper on your snack, The hidden plastic lining inside your paper coffee cup?
Stuff we don't even think about.
Right. We use this stuff for 5 minutes and stays inside our ecosystem and our bodies for 5 centuries.
And this specific absurdity is what drove Neha Jain, a journalist who spent 5 years working at Google, to walk away from tech and start a company called Zero Circle.
Wow, quite a career change.
Yeah, she asked a fundamental, glaring question. Why does the temporary material touching our food have to be made from imported fossil fuels, often laced with toxic forever chemicals known as PFAS, just to keep grease from leaking through?
Her solution is wild. She is growing alternative packaging in the ocean.
She is farming seaweed.
Seaweed?
Yeah, seaweed is an absolute miracle feedstock when you think about it. It requires no fresh water to grow, no chemical fertilizer, no pesticides, and absolutely no arable land.
So you don't even need a farm on land.
Exactly. That means it doesn't compete with food crops the way corn or soy-based bioplastics do. Zero Circle takes this seaweed, farmed by local coastal communities in India, and turns it into home compostable packaging.
Okay, hold on. I need to jump in here because whenever I hear the word compostable, I roll my eyes a little bit.
I know exactly what you mean.
We've all used those terrible paper straws that dissolve in your iced coffee after 3 minutes. But then if you throw a so-called compostable bioplastic cup in a normal landfill, it just sits there for decades.
Because it needs a specialized industrial heating facility to actually break down.
Right, so is this seaweed stuff actually different or is it just greenwashing?
It is fundamentally different at chemical level. Most commercial bioplastics like PLA are synthesized polymers.
Okay.
They're essentially plastic made from plants, so they still have chemical bonds that nature doesn't easily recognize. Seaweed, however, naturally contains complex sugars and natural polymers that marine bacteria and soil microbes already know exactly how to eat.
Oh, that makes total sense.
Yeah, Zero Circle is utilizing these natural structures so that if the packaging ends up in the dirt or the ocean, it biodegrades natively without needing a massive industrial composting oven.
The autonomy equation here is brilliant. The dependency broken is the reliance on imported petroleum and toxic chemicals for everyday consumer materials.
Exactly.
And the capability built is a homegrown, ocean-based material supply chain that actually cleans the water while it grows. But the sources highlight an unlock that makes this an actual viable business, not just a cute science fair project.
This is the best part.
Zero Circle engineered this seaweed plastic to drop straight into the legacy packaging factories that India already operates.
And that is the make-or-break detail for any green tech. If you invent a miraculous green material, but you tell every manufacturer in the country they have to spend $20 million tearing down their factory to build new machines to handle it, your product will fail.
Period. Nobody's going to adopt it.
Nobody. Zero Circle engineered their seaweed film to stretch, heat seal, and block grease using the exact same thermal and mechanical properties as conventional plastic.
That is so smart.
The industry can switch their raw material without ripping out their existing infrastructure.
And seamlessly, this links us to our final company, Nutrace. Because just as Zero Circle is trying to replace fossil fuels in our physical materials, Nutrace is trying to replace fossil fuels in our industrial energy. Specifically, they're going after hydrogen.
Hydrogen is the invisible workhorse fuel of the modern world. We consume millions of tons of it globally to refine petroleum, manufacture fertilizer for our crops, and produce steel.
It's everywhere.
But currently, almost all of that hydrogen is extracted by burning fossil fuels. It's a massive hidden source of global carbon emissions.
Now, the solution exists. We have green hydrogen, which is made by taking clean electricity from solar or wind and using it to literally split water into hydrogen and oxygen. Zero emissions.
It's like magic.
The machine that performs this magic trick is called an electrolyzer. But to build a traditional electrolyzer, you have to rely on delicate, imported polymer membranes and incredibly rare imported metals like platinum and iridium.
Which creates a fascinating double dependency. You're trying to escape your reliance on imported Middle Eastern oil.
It's like trying to bake your own bread, so you don't have to rely on the local bakery, but then realizing you still have to import the oven, the yeast, and the flour from them.
Exactly.
You haven't actually made yourself independent at all. You've just changed what you're buying.
If you have to import the machine that makes your clean energy, and you have to import the critical rare earth metals inside that machine, your sovereignty is an illusion. You're just a hostage to a different supply chain.
Right.
This is the genius of Prasanta Sarkar and Roshan Singha, the founders of Nutrace. They completely reinvented the architecture of the electrolyzer by building it with no membrane whatsoever.
Okay, I read that in the dossier and I was completely confused. You're splitting water into hydrogen and oxygen? Gases naturally expand and mix?
Yep.
And if hydrogen and oxygen mix, they become highly explosive. How on earth do you keep an explosive mixture of gases apart without a physical wall between them?
They utilize advanced fluid engineering. Think about the physical flow of a river. If you control the velocity and the currents perfectly, you can direct objects exactly where you want them to go.
Okay, I'm with you.
Nutrace designed a system where the precise flow of the liquid water itself, combined with natural buoyancy, acts as a dynamic barrier.
Wow.
Yeah, the current physically sweeps the hydrogen bubbles out one channel and the oxygen bubbles out another before they ever have a chance to touch. By dropping the physical membrane, they eliminate about 70% of the moving parts and failure points in the machine.
That is wild. And they didn't stop there. The dossier says they also developed a proprietary electrode technology that swaps out the rare imported platinum and iridium for abundant Earth-common metals that can be mined directly in India.
They broke the fossil fuel dependency and the imported materials dependency in one fell swoop. A simpler machine with fewer parts, built entirely from local materials, making limitless clean fuel.
It's incredible.
And what's vital is their target market. They aren't building small consumer units. They're building massive, high-capacity electrolyzers aimed squarely at heavy industries, steel, refineries, fertilizers, the sectors that pollute the absolute most.
The big polluters.
Right. This aligns perfectly with India's massive green hydrogen mission, which is a 20,000 crore rupee government push, creating a massive tailwind for their tech.
I have to play devil's advocate here, though.
Yeah.
Hearing all of this, it is so easy to get starry-eyed.
Oh, for sure.
It sounds like India is about to take over the world tomorrow, completely independent, wrapped in a nice compostable seaweed bow. We need an honest reckoning.
We definitely need to inject some calm realism into the room. Deep tech is brutally, unforgivingly difficult. The companies we're talking about are building foundations, not finish lines. Take Sarvem AI, for instance. They're achieving incredible things with frugal engineering, but we have to acknowledge they operate with a tiny fraction of the tens of billions of dollars that global giants like OpenAI or Google are deploying every single quarter.
Yeah, the scale of funding is just completely different, and Sinilar software is just code. But Sinilar is trying to put physical robots onto live, chaotic factory floors. If they mess up, an entire automotive assembly line grinds to a halt.
The stakes are incredibly high. Sinilar is taking on entrenched, multi-billion-dollar global automation giants who have decades of relationships with these factories.
Yeah, they're not just going to give up their market share.
Exactly. Rolling out a brand new, highly complex robotic vision system onto a live production line takes 12 to 24 months of grueling deployment cycles. It is a slow, agonizing process to turn a flashy lab demo into millions of reliable, error-free factory hours.
And Zero Circle has the same monumental uphill battle. They have to somehow match the pristine performance of conventional plastic while simultaneously trying to beat the price of dirt-cheap petroplastics at massive global scale.
The graveyard of green materials is full of beautiful, noble products that worked perfectly in the lab but couldn't compete on price by a fraction of a cent on a supermarket shelf.
It all comes down to cost.
Yep. And Nutrace has to prove that their novel, fluid dynamics, membraneless design can scale up from 20-megawatt pilots into reliable industrial-scale energy plants that run flawlessly for decades under incredibly harsh, high-pressure conditions.
So it begs a crucial question for you listening. Are these frugal engineering bets doing more with less, relying on first principles rather than massive budgets? Are they enough to actually dethrone trillion-dollar global monopolies? Or is this just the first necessary step into the arena?
That is the defining question for the next decade of Indian technology. They're finally stepping into the arena, building the foundations, but foundations are just the beginning of the building.
So what does this all mean? Let's tally up the autonomy ledger for this entire deep dive.
Let's do it.
We've explored a shift from relying on foreign digital brains that think in English to homegrown AI fluent in 22 languages, alongside air-gapped code that keeps defense secrets secure.
Huge shift.
We've gone from rigid, imported factory robots to adaptable robotic hands equipped with true object intelligence. We've moved from importing petroleum to make toxic plastics to farming compostable materials in our own oceans.
Right.
And we've seen the total reinvention of clean energy machines, stripping out imported membranes and rare metals for abundant local resources.
Yeah.
India is fundamentally transitioning from a passive consumer of global intelligence and materials into an active builder of them.
It completely reframes how we should view national independence. We traditionally think of sovereignty in terms of massive macro concepts, borders, standing armies, international treaties.
The big stuff.
But what if true sovereignty in the 21st century is actually microscopic? It's determined by the invisible layers of our daily lives.
Yeah.
Who writes the code running in your pacemaker? Who designs the vision algorithm assembling your car? Who owns the invisible membrane in the fuel cell powering your factory?
Those are the questions that matter now.
The next time you hold a piece of plastic packaging or read an AI-generated answer on your phone, I want you to ask yourself, whose intelligence built this and who actually holds the power to turn it off?
That brings us right back to that house we talked about at the very beginning. If someone else holds the master key to your electricity, your language, and your tools, it doesn't matter whose name is on the deed. It's not really your house.
Exactly.
But as we've seen today, these companies are finally changing the locks. And it leaves me with one final thought to mull over. If we are successfully reclaiming our code, our factories, our materials, and our power, what is the next frontier of independence?
That's a great question.
I can't help but think about biological sovereignty.
In 10 years, will we be asking who owns the genetic sequencing data of our citizens? Or who controls the intellectual property of the synthetic seeds our farmers plant to survive climate change? Now that is a whole other deep dive.
The battle to own the master key is only just beginning. Until next time, keep diving deep.